Hello, am I audible?
Sir, good afternoon, sir.
Good afternoon. Good afternoon. Am I audible? I think
Yes,
yes.
sir.
So जरा देख रहे स्क्रीन पे क्यों नहीं आ रहा फोटो?
Yes, sir, audible, sir.
Okay.
So we'll wait for 2 minutes, sir. Then we'll start, sir.
Yes, please. Okay. Okay. We had some time. At least 2 minutes are there.
Yeah, yeah,
And
sir.
you told me that participants are because there are only 19 participants. Maybe
Yeah,
we need
yeah,
to wait for 10, 12, 5, 10 minutes.
yeah, yes, sir.
Okay. These are-
Sir, shall we start, sir?
Yes, please, sir. Yes, please.
So, good afternoon to the Professor Mukesh Kumar Singhal, sir, and my dear participants. I welcome you all for the 2-week online faculty development program on renewable energy interventions in industry, domestic, and commercial application. So today we have with us Professor Mukesh Kumar Singhal, sir. Sir is a professor of hydro and renewable energy. Sir is going to deliver a talk on hydropower investigations and assessment. So let me introduce the Mukesh Kumar Singhal, sir, to the participants. So, sir received Bachelor of Engineering from Civil Department and a Master of Engineering from Structures and a PhD degree from Indian Institute of Technology, Roorkee, and currently working as Associate Professor in the Department of Hydro and Renewable Energy at Indian Institute of Technology, Roorkee. So, sir is actively involved in teaching, research development, and consultancy work for investigation, planning, designing, preparation of DPRs, technical specifications, techno-economic evaluation reports, costing and financial aspects of SHP projects for last 36 years. Sir also supervised 76 MTech thesis and published 46 research papers in international journals, national journals, and conferences. Sir, current research include development of software for computer-aided planning and designing of civil works of SHP projects. Sir is involved in planning, designing the SHP projects and evaluating the DRPs for SHP projects for different state governments and private institutions. So, Sir has visited USA, Canada, Germany, United Kingdom, Nepal, and Bangladesh in relation with training and research in the field of SHP development. So this is very short and brief bio sketch of Professor Mukesh Kumar Singhal sir. And for complete details, you may log on to the IIT Roorkee in Civil Engineering Department. Sorry, under Hydro and Renewable Energy Department. So at the outset, I would like to thank Professor Mukesh Kumar Singhal sir for accepting our invitation to give an expert talk for participants in this afternoon. So thank you, sir. So please deliver the talk on this afternoon.
Thank you very much. So now I will share my screen first.
Yeah, please, sir. Sir, any problem, sir? Sir, any problem, sir?
चल रहा है यहाँ घर से, लेकिन मेरा स्क्रीन शेयर नहीं हो रही है। तुम कर सकते हो? अच्छा, ठीक ठीक।
Sir, any problem, sir?
हाँ, yes please. Actually, I am not able to share my screen.
So you share, sir. We have given the permission to you.
Okay, let me
Sir,
again
you
go.
have joined in two names, Mukesh Kumar Singhal and Mukesh Kumar Singhal with two IDs.
Actually, yes, I had tried. Let me check it again. I will just again join. I'm going out and coming back.
Okay, I have given for both the names permission. You please share, sir. So there is a share screen option at the bottom.
Hello, Mr. Reddy. Am I audible?
Yes, sir. Audible, sir.
So, host disabled attendee screen sharing. Again,
Yeah,
the
I have
message.
given permission.
Yes. I think my screen is visible to everybody, Mr. Reddy.
Yeah, yes, sir.
Okay, then. Uh, Good afternoon, everybody. Are you able to see my screen now?
Yeah, yes, sir. Yes, sir.
Okay. So, very good afternoon to everybody now. The topic of my discussions is hydropower potential assessment and investigations. And as introduced by Reddy about me, actually, since 1983, I'm in this center. At that time, the small hydro was just started in the country, and we were asked by the DNES. At that time, ministry was a department of DST and Department of Non-Commercial Energy Sources, and they asked us to set up 3 demonstration projects. One project was on 1.5-meter head on canal. Other 2 projects were one in Manali, Himachal Pradesh. The third one in Jubbal. And in Manali, we just tried to run our pump in turbine mode. So after that, a lot of development has is there in this sector, and basically the energy is important for the development. Any development can be linked in with the energy consumption, and energy we require for trade and commerce, for the production in industrial production, transportation sector. We everybody knows it now that we are shifting from petrol vehicles to our the battery charge vehicles. And this agriculture sector, at that time we were having, earlier we used to have a few hour electricity available for our the farmers. Now states are trying to give the free power or power at a nominal price so that the agriculture production may be increased. The domestic needs, a lot of electrical appliances are coming up day by day, and we need the electricity for them. And in service sector, you know that in service sector there is a shift in the trend. Everywhere the sector needs developing a infrastructure. Maybe most of the office buildings are becoming air conditioned, so that we can get a more productivity for our the workers. Now earlier we used to have the conventional source of energy, a thermal project, a hydropower project, a nuclear project. Now after that we had other sources, non-conventional sources of energy were solar, then wind, biomass, small hydro, geothermal, and tidal. Just see, the hydro has coming in conventional source of energy as well as non-conventional source of energy also. The difference between these two categories, in this hydro, the conventional source, what we were doing, we were just constructing a dam across a river, and we were storing a water, rising the water level, then by 100 or 200 meter, then we are falling the water from that height, so for energy generation. But in case of small hydro, we don't store any water. We just whatever the water is available in the river, that is being used for power generation. So difference between these two is, so actually during our monsoon period, we have around 20 times of the discharge available in our river. So in case of conventional source, all that water was being used by storing it. But in small hydro, we don't store. So that during monsoon, a lot of water goes waste. But you know that so due to limited source, there actually problem of the conventional energy. So problem, everybody knows it. The problem in thermal, environmental pollution is there. Problem in hydropower, because if we construct a dam, so a lot of area getting submerged. And you know that in hydropower, sometimes you will find, just like in Tiri, there was a lot of resistance from the local people due to submergence. There was one project in Arunachal Pradesh having a potential of 30,000 megawatt, a biggest hydropower project in a country. And 2 years we had the investigations by central agencies. But what happened, by the construction of dam at the site, a lot of submergence of the then chief minister area was going to be submerged, so permission could not be got from them. So due to these limitations, now we had switched to non-conventional energy source of energy. Now this is our the Indian electrical scenario. We at present we are having around 3,77,000 of the power installed, means 377 gigawatt. And you know that out of these, the major contribution comes from our coal and lignite projects, is around 206 gigawatt. But you know that now we had a lot of problem was there since starting. But now you know that we are shifting our focus from these coal projects to our the hydro projects, and to our renewable projects. It has gone to 92,000 megawatt, because of mostly because of solar only. Now this is a state-wise, the sector-wise. State sector, because our the power generation is a state subject. So the state government owns around 103 gigawatt of the power. Center, because a lot of projects are being funded by central government also, around 94 gigawatt capacities are owned by them. And private sector has come in a big way, and 50% of the power which is available at present are now are owned by them. Now the renewable energy contribution 92 gigawatt, and major now the maximum has come to solar power. It is because you know that earlier the wind energy was maximum, but now solar has taken over, and now we had a lot of potential, lot of plan for solar development. Maybe 2 lakh 200 gigawatt 2 lakh megawatt projects are to be developed from the solar energy. Now I come to the hydropower. Basically hydropower energy which we got it is the 9.81 discharge and head into efficiency. Actually this is basically a potential energy equation which was mgh. G is 9.81, m mass is converted into a discharge, h is head here. So this is a efficiency because all the equipment, this is a pure is the potential energy equation, and it is to be multiplied by some factor, because we cannot convert, we cannot get 100% electricity from convert 100% potential energy into electricity, because all the equipments which are being used in this power generation, they had some efficiency. So to take care of the efficiency factor has come up. Now this what this had is yeah, this is had is the potential had means power is generated at powerhouse, and water is available at a diversion point, from diversion point. So the difference between the elevation of these two points is the head, as in case of potential energy also. Now efficiency of our the equipment, when we generate the power from our the hydro project, we had first is the turbine, then generator and gearbox. So I show here, this is in powerhouse, the potential energy or hydraulic energy is first converted into mechanical energy, because this energy rotates the shaft of our turbine. This shaft is connected to generator. From generator we develop, we convert the mechanical energy. First is the hydraulic energy to mechanical energy, and from mechanical energy we go to the electrical energy. So some efficiency loss due to turbine, some efficiency loss due to generator. Now the sometimes the generator and our turbine, they had different rpm. So to match the rpm, because the turbine is generally rotates at lower rpm, and maybe in the order of say 500 600, generator could be rotating at 1000 rpm or 1500 rpm. So there is a mismatch of the rpm, so we need a gearbox in between. So a 2% efficiency loss is there due to gearbox, and combined efficiency will be the turbine efficiency multiplied by generator efficiency multiplied by gearbox efficiency. And in turbine efficiency you just see it is 88% to 94%. Why it is so low? Because you know that turbine, when initially the turbine is at zero speed, and suppose the rated rpm at which the power is generated, it say suppose 500 rpm or 600 rpm. So from zero the machine, when you start opening the valve, so water start going and it start rotating. But if it is rotating at first 0 rpm, then 100 rpm, 200, no power generation. Only it is energy which is available is consumed in running that turbine of that rpm. When the turbine reaches to rated rpm of 500 600, till that all energy available is wasted, means it utilized in running that, because sometimes the runner diameter of the turbine is 1 meter 2 meter. So 2 meter mechanical disc rotating at a rpm of 500 need a lot of energy. So that is that is converted, that is accounted in efficiency of turbine. That's why the efficiency of turbine is 88 to 90% to take care of that energy which is required to run heavy part at 500 rpm. Now So hydropower which are there, so they can be classified on the basis of some I had shown a various categories, say by size. So large is any capacity of hydro 1000 megawatt, up to large, medium and small. So small starts 25 megawatt, then mini, micro and pico, they are of smaller range. So micro is up to 100 kilowatt. In between 100 kilowatt project to say 25 megawatt, mini projects will be around 5 megawatt project. From 5 to 25 is small. Why these categories are required? Actually, you will find a lot of changes in the technology, and government actually, these large and medium projects are commercial projects because they have to be designed and developed on the basis of commercial basis. But small, and mini, these projects get some subsidy from the central government because to make them commercially viable. Micro projects is 100 kilowatt, so they get around full subsidy. Around 90% of the project cost is met by the central government or state governments. So that's why we need a lot of categories. Now come to the head. We had two category of high and low. Actually, basically high head projects, it is a different type of the, we had three categories of the machines. So we can say high, medium and low. So in high we had a Pelton turbine. In medium range generally we have a Francis turbine, and when it is a low, low is a axial flow turbine. So because of the due to this head classification, we know which type of the machine to be utilized. With the size we know if we are getting a subsidy from government or not. And the purpose is single or multi-purpose. Actually what happens when we it basically this category comes for our large hydro project, say our TD project. Okay. And we had a project, in TD projects we had the dam constructed which supplies the water for our power generation. But this supplies the water for our irrigation channel also, if there is irrigation. Yeah, so irrigation channel you will see taking off from the dam, upstream of dam. So it becomes a multi-purpose. So the multi-purpose generally could be a irrigation, power, drinking water, and from tourism point of view. Now fourth category is storage purpose. I told you runoff river is when we don't store any water. Whatever the water is coming is being utilized for power generation. And this is a storage, if you are creating a lake or pond. And now is seasonal. What happens, so this is just to when you just store the water for some period, and this utilized for power generation. So this is based on the storage capacity. Now with the function is generally, you know that the project is for most of the project, hydro projects, earlier projects was for power generation only. But when we had a renewable projects, solar and wind, their energy is available only for limited period. From solar we get a power during daytime only. During night time, zero power. For our the wind projects, when there is a wind we get a power, otherwise not. So what happened, so what to do with the remaining period? So for that purpose we need to store the energy. So that the concept has come from pumping. Means what happens when the energy is surplus in the grid. Actually that energy is consumed by running our pumps, so that the water which has flown back to the river is pumped to the higher reservoir. And when there is a shortage of energy in our grid, that stored water can be utilized for power generation. Now third category is the reversible. Means actually in reversible we had a turbine which runs in reversible mode. When it generating power, it is in turbine mode. When it is so same machines can work as in can be run in pumping mode also. So they becomes reversible. Now, the one category could be a service type, a base load. Base load means yeah, the you know that we know that what is the average energy requirement in our grid. So generally, our thermal project just meet that base load. Means that they are continuously running. But thermal projects require few days or hours to shut down or to go to the maximum speed. But you know that recently we had a call from our prime minister to close the project at 9 p.m. for 9 minutes. So around 18,000 megawatt of the load was shut down in say within a period of say 9 minutes. It was a call, and again it was resumed back. So only the duration available was for 9 minutes only. So the base load station cannot meet that requirement. It is only earlier actually our hydropower was getting neglected because of the high generation cost. But this type of the requirement that we call a peaking requirement, that can be met only with those projects which can be operated, switched on and switched off within seconds or minutes. You can say solar may be of that may come in that category, but the problem is solar are not available throughout the night. So it is only our the hydro projects which can meet this type of the requirement. So the peaking projects, peaking requirement, that's why we say that hydrothermal mix for the stability of the grid. Actually, why the term stability of the grid is dependent on hydropower. This when actually you require more power, suddenly our the frequency gets low, and as the frequency goes down, our projects get start getting tripping. Similarly, if suppose the demand is not there and generation is there, frequency goes high in the grid, again our systems start getting tripping. So for the stability of grid, it is only the hydro projects which can meet that requirement. So so that's why now that focus has been given to hydropower and basically to the pumping stations, because this is a very wide area where, and because they are also a hydropower. So so when you had a extra surplus power in the grid, so you know that that power sometimes it available free of cost, because for the stability of grid. So the grid management cell can ask, sir, we take this power free of cost, even we will give you some amount to take that power, because otherwise our grid will collapse. So that is a economics of pumping stations, because when the power is very cheaply available, use that our pumping for storing. And when the energy price is as high as 7 rupees, 8 rupees, then use that stored power for power generation. So they work just like a battery backup. Now so base load is thermal, peaking is hydro, and intermittent is peaking is to maximum. Peaking and intermittent, you can say same category. Now, by system design, standalone and cascading. So if you are developing a project in isolated mode, or sometimes you find a lot of project on the same canal, just first project, then and when the project's water is released to the river, again one more project will come up, then third project will come up, that is called cascading. And now the by the type of scheme and storage are same. Okay, because it is run of river, dam based. When you construct a dam, canal based. When you are developing the fall available in canal. Now, so run of river, I discussed a lot. No storage, output subject to the whatever the discharge is available. And now canal based, so utilize the fall available in the irrigation canal. dam based. Actually, a dam based is the dam to be, because I'm discussing runoff river or dam to based basically. So you are not constructing any dam, you are utilizing already existing dam available. So a lot some when the surplus water is there, that water get wasted from the spillway of that dam, so that can be tapped for power generation. Now, so this is a typical runoff river hydro project. When you're there is a the water is going waste. Water is flowing in the river. So we divert the water for power generation, and we that water is taken through the open canal up to the a tank at the end, that is called 4-way tank. From there we just take a pipe for our power generation at the powerhouse. After the power generation, water is released back to the same stream. So this is a very typical type of a hydropower project. Now, second type of the project are canal based project. Actually, all our irrigation canals are having mandatorily, you can say, the fall in the system. Why? Actually, the irrigation channel having a very mild slope, maybe 1 meter bed slope in 5 kilometer. You cannot visualize is there as in any the bed of the canal is having any slope. So, but our terrain means normal ground has a steeper slope, maybe more than 1 meter in 1 kilometer. So it means our ground is sloping 5 times steeper than the irrigation canal bed level. Means after 20 kilometer, after a length of 20 kilometer of irrigation, our channel slope is always higher. Our channel bed is always higher than the ground. So initially we just make it up by making a filling here. But when the filling becomes too much, so we provide a fall in a irrigation system, so that we just cut our the land and put this land for filling upstream. So this becomes a fall. These falls can be generated, can be developed for power generation. Our center, personally myself, is involved in development of 21 falls in our Bihar project, Bihar. So they are around 20 megawatt of the projects, and all these projects are being developed in consultation with our center. And you know, a lot of innovations were done by our center to meet the problems which we face at these places. Now, the dam to base project, which I just told, that what happens, a lot of time this water is going surplus water is going waste through these spillways. So those so we can have these are the under sluices already available in the dam body. So we can connect our pipe which is used for power generation. And these are the we just develop a this powerhouse which utilizes, which generate the power. Now, I had shown the pumped storage configuration. It is upper reservoir, machines, and lower reservoir. What happens? Water is from upper reservoir comes for power generation at this project, and the water which is released again is stored at lower reservoir. When we had a surplus water, surplus energy available here, so that is used to run these the machines in a reversible mode. They just run the machines in a reversible mode. They just upper reservoir. Now, as an example, the dairy project normal generation megawatt, but with the in the reversible mode, in a pumped mode, it increases to 2000 megawatt. What happens? They had a lower reservoir here, so during off-peak hours, 1000 megawatt turbines are run in reversible mode to just pump the water from lower reservoir to upper reservoir. So, and during peaking, so the water which is already available coming from the upper river is stored here. The water which is pumped back from lower reservoir is stored here. So it becomes double of the capacity. So now with pumped storage, the generation capacity of Tiri Hydro project has gone twice. It is 2000 megawatt project. So during that time, the 2000 megawatt of the energy can be generated from these machines. So so that's why just to meet the peaking requirement. Now this is a sketch showing this is the upper reservoir, and we had a project here. So water is released downstream. So we had a dam on the downstream side also. So this the water after power generation is stored in this reservoir. No, now during off peak hours, water is pumped back from here. It is stored here, and during peaking, the total double of the discharge comes from this reservoir for power generation. Now, so the resource assessment for SHP. Actually, for our we need to so it is a first we have to duly shared between the governments because it is a state subject. So so different, and generally the projects are multi-state projects. If it is a bigger size project, because if it is a 25 megawatt or 100 megawatt project, maybe it is stored in the it is located on one stream only, which is a state subject. But once it is a boundary of the state and two states are there and central also coming up, so the sharing, because you know that when the project is to be developed, every state is to fix its share, so that some part of the power generated comes as a royalty, and some parts on the basis of investment done by the government. And social and private sectors are also involved in development of these projects. Inventory of all possible sites. Actually what happens, earlier when we started, a lot of projects come up with the government for resource identification only, because HEC was involved in development of so under UNDP project, which was came to MNRE to develop to assess the power potential sites. And first 400 sites in Himachal Pradesh, and also around in the same range in Uttarakhand also were being assessed by our center at that. Actually our center was alternate hydro energy center at that time. Recently, it was converted to Hydro and Renewable Energy Center. So HSC was involved in development of in potential assessment of all 13 hilly states. So inventory of all possible sites are required. Then provide priority or ranking. You know that all these 400 sites, say it was total was around 1700 sites. If you say on the all India basis, cannot be developed in one go. So you need to make some ranking. Maybe those sites which are easily accessible first, very close to load center. Okay, so and you know that all sites are not can be developed in same price. So sometimes some sites need a very small, very compact the power structures for power generation. So these can be developed first, means where the generation cost of the electricity, means you just whatever the potential is available. So you just calculate how much energy can be generated from that project at what cost. So those projects which generate the power at minimum cost, they are ranked first. Then we need to find out the clusters, because you know that sometimes if suppose there is a small projects of 100 kilowatt, 10 kilowatt, 20 kilowatt. Okay, so we had a MNRE scheme to develop 100 projects along Indo-China border. At that time it was under border illumination program. So those 100 projects were identified, so that each household along our border, China border, can be illuminated. So so many schemes comes up likewise, and recently some scheme has come up for J&K. So under these schemes, the state governments or concerned agencies keep on just getting the resource assessment, so that whenever the funds are available, so those projects can be developed. So now this is a project cluster, because you know that if suppose we know that why it is very important. You know, in our Himachal Pradesh, a government, because of the government policies available, a lot of projects were coming up. Okay, what happened? Every project were generating a power and transmitting. So generally, if it is an individual project, it can be transmitted on 33 kV. So everybody was 11 kV or 33 kV lines were heavy. What happens when the project capacity goes beyond 15 megawatt? Then you cannot, the power on 33 kV can be transmitted only up to 5 kilometer, very small length. Then you have to go for a bigger transmission system of 132 kV. Means for 132 kV, the cost of the transmission line is around 1 crore per kilometer. It cannot be met by the private developer. A government has to come up with their plan. So for that one, if you identify the cluster, identify how much power can be generated in that cluster, then make a proper plan. You know that recently I had a presentation in Arunachal Pradesh, and even you know that at that time the chief minister was available throughout the day there, and they had just they are just discussing about the plans for development of around 10,000 megawatt. And you know that they were having around 400 megawatt projects were clear technically. I just mentioned, sir, you cannot develop even a single project. Why? Because generally project capacities are 15 megawatt, and 15 megawatt projects cannot transmit the power on 33 kV more than 5 kilometer. It means till government plans their 132 kV transmission network, they cannot be developed. So actually, you know that we just can plan so many things, but finally bottleneck becomes something different. So the cluster is so important, and certainly the financial requirement is always there. If you want to develop a project, you need a finance to develop and provide grid network strengthening, which I am discussing to here now. Yeah, for the scientific for the SSB development, you know that we don't have a systematic study. You know, sometimes the projects generally what happens, we it is being assessed by a government agencies having their project officers at district level. So they keep on sending some information, then on that basis headquarter keeps on gathering information. Maybe we just see that if we want to develop a project area, so we need to go in a systematic way. So so oftenly we are just having the individual basis, and but you know that as the time passes, the individual projects becomes in a cluster mode. So could be maybe after 5-10 years a lot of data will be available, then we can make some integrated planning. Now, integration of other development like irrigation, drinking water, industry, and you know that when we are having whenever we are planning some project, we should find out how much is the irrigation requirement in the area, so that we should make a sufficient provision for that purpose. Now, the potential assessment, which earlier it was a CEA who has just assessed the number of sites and the potential. And then the HEC came, first project HEC got from PFC. So we identified on the basis of the topographical survey sheets which were available with us, and around 4,000 sites with 8,000 megawatt. Then MNRE just sanctioned one more project. So finally, it was reached to around 16,000 megawatt, and with around 6,000 site. Now, the one more term has come up, a plant load factor. Earlier, the plant load factor was 75%. Now, a plant load factor of 25% is also acceptable. What is this? Actually, is the utilization of machine. Means the machines which are put up in your project. So if suppose they are say of 10 megawatt machine, so 75% is 75% time in a year they should develop a 10 megawatt. So it means if you are getting more power, more discharge during monsoon, so only 10 megawatt corresponding discharge is utilized for power generation, other is going waste. But now the PLF plant load factor can be as low as 25%. Means the machines which are put up in your in the grid at the project, so they should if suppose there are 10 megawatt project, so the 10 megawatt power generation should be for 25% time in a year, because that means in a monsoon we should try to utilize the monsoon discharge as much as possible. After that, when the monsoon period is over, our discharge is reduced. So so it means so plant utilization becomes around 25%. After that, maybe out of 4 machines 2 are closed, and remaining 2 machines will generate 5 megawatt. So that's why the total plant if we allow the lower PLF for the project, so our potential hydropower potential has increased correspondingly. Now resource assessment will be runoff river, storage projects, existing dams, barrages. So wherever, yeah, I had discussed in detail about the canal falls. Basically, this is in plain area. This is in Uttar Pradesh and South and the Bihar, and existing irrigation dams and storage projects are in hilly area. So on that basis, we just can develop. We have to make. We have to go for resource assessment, and several opportunities. Although it is very small, like the in pipelines which are we are having for drinking purpose. So very small schemes are could be maybe around 1, 2, 3, 4, 5 kilowatt at the effluent of water treatment plants. Actually, when we are having a treated water from our sewage treatment, so sometimes that discharge when it meets to the river, it has a fall of 10, 20, 50 meter. So that can be used for tapping the power. Now there is a smaller turbines of hydrokinetic type around 50 or 100 kilowatt. Actually, the flowing water in a river or a canal, so if it has a velocity of 2 meter or more, so that can be tapped for power generation of 50 to 100 kilowatt systems. And these machines can be put together in a canal to generate around 500 kilowatt of the power. In small scale pumped storage plants, so the pumped storage which I had discussed about the Tiri dam can be implemented on a smaller size project of 50 to 100 kilowatt. Now, for resource assessment again, we had a computer-based tools. Although now computer-based tools is actually we had developed a models which can estimate the discharge availability, and the head which we require. We had a topo sheets available from Survey of India. So on that basis, we can estimate what is the potential of the sites. So this is combined together we call a geographical information system, and remote sensing. Satellite images are available. On that basis, some study can be carried out. So conventionally is the topographical survey sheets are available, and some softwares are also available which can help us in estimating the power potential. Now The conventionally what we do, this is a so suppose we are developing a project at this location at the tip of this one. So the rainfall is there in the area. Okay, so which is the rainfall enclosed by this boundary, that is called a catchment area. Actually what happens, so generally it is the top of the hills all around, and after that if the rainfall is there on other side of this line, it flows through the different rivers, and the water which is falling on this line or within this area comes finally to this our the point of the diversion. And you know that because I had taken this figure from our topo sheet. So basically, the blue line is shown in the topo sheet, means 12 every time in the year that some discharge is available here at this point. So it is a perennial rivers, and at the top of the hills these streams are black type. So the topo sheets, if these lines are black, never put a project here because they are only seasonal one. And finally from where you see a blue line, it becomes a perennial. So there could be a question, why the black line becomes a blue line once everything is black at the top? So why we are seeing blue somewhere? Actually what happens, the water which these black lines have, it is only the rainfall. But generally in the rainfall the water flows through these streams, but after this time no water is available. But some of the water in this area goes inside, percolated inside. So where you see a blue line, that water after traveling now comes at the surface here. So that's why every time in a year you see a water flowing. So you know that's why so always put a project at this blue line, and you just draw a catchment area line. Very accurately you can predict, because and topo sheets are available for the whole area in our country. So you can plan the discharge available at this point by measuring a catchment area, then comparing this catchment area with the adjoining streams where the discharge is available for longer period. So you can have some feeling of the discharge availability. So now in our when we had planned for 13 hilly states, so we just developed a regional, means for all states we just develop some regional flow duration, so that we can assess the discharge available for ungauged catchments. So now the for hydropower potential we computed, and it was 50%, 75%, and 90%. Means so by the 50% dependability, means we just find out how much that discharge is available for 50% time in a year. So 75% time in a year, 90% time, 90% time minimum. It means we need that discharge should be available 90%, means around kitna time ho gaya, 12 around 10-11 months. So it is the minimum discharge used for power generation. When we just allow to 50%, means 6 months time in a year. So we just covered monsoon period, and maybe 3 months before monsoon, 3 months after monsoon, that whatever the maximum discharge available for at least 6 months we utilize. So out of these three figures, maximum potential we got with 50% dependability. That exercise we did under UNDP. So this is a cascade development. What happens? One project so develop, then we release the water in the river, and second projects likewise is a cascade one. So this is we had a master plan of MP where we just developed the sites in cascade mode. Power transmission network is very important, which I discussed. For this is study also we had developed this it was not our work, because we need some data from the government agencies. So firstly we asked for the power network so that we can plan the project. You know, in one of the meeting at MNRE, I was there with for JNK. So they were to sanction around 20 projects of say 1 to 3 megawatt. So the concerned officials from JNK, they just asked, sir, We don't so this reduce the capacity from 10 for 20 of these to 20 projects to half or less than half. Why? Because we have only 11 kV grid there. I just submitted there, sir. 11 kV is not a grid. You have to consider 33 kV as a grid. And sir, out of these 20 megawatt, don't reduce the 20 megawatt to 10 megawatt. Only just take out 1 megawatt project. One megawatt will cost around 10 crore of rupees. And under 10 crore, sir, you can plan for all these projects 33 kV network. It is not that much costly. 33 kV can cost around 50 lakhs per kilowatt. So, sir, so that's why if we plan judicially, so we have to plan up to the end. Water is available. Okay, go for power generation. Uh, how to take that water for the consumers? That is more important. That comes from power transmission line only. So this is one of the project for which we prepared the DPR. You just see in a cascade mode. This is a river going. We just have a diversion, took out the water, so use that water for power generation, release the water in the river again, that water flows in the river, then again we just tapped by putting a diversion, utilize it. There could be a question, why can't we have a directly this line extended and up to this point? Could be, but you know that at that time, you, if suppose you are releasing the water here and tapping it again, the catchment area here it will be up to this point. So, and at this point the catchment area will be much more. So maybe at this time the twice of the catchment, twice of the discharge can be utilized for power generation. So it is a study which you have to compare whether should develop a project, total project, then a lot of structure will not be required. Maybe cost may reduce drastically. And you know that one more thing is there. If suppose you had an option of developing say 10 megawatt, there could be various locations along the river. Suppose you want to develop a project of 10 megawatt, you had a choice. Either you use 10 meter 100 meter head, then more discharge is available, or you just shift the diversion point to slightly above, so that the head becomes 200 and you can reduce the discharge half, potential same. Which to be selected? Always select a higher head scheme. Why? Because the higher head scheme of 10 megawatt means, if suppose you had a scheme of 10 megawatt of 100 meter head, 10 megawatt of 200 meter head, your 200 meter head scheme will cost you around 75% of the cost. Why? Because if you are utilizing, if you are using a less discharge, your civil cost will reduce, your E&M cost will reduce. So whenever you had an option of developing a project for higher head, always go for it. So, but you know that but it is contradicting here. If suppose you are developing a project 50 meter here, then a 50 meter here, so why don't you develop a project to combine together 100 meter? Because could be you are getting a more discharge at this location, so that you can develop more power. That is so simple. Now, regarding the various alternatives availability, you know that if suppose you are having this is a dish of water flowing, so you just have a power channel to take the water and utilize here. The other alternative could be you just make a tunnel. So many alternatives. So you keep on stating, it is not that you can make a guideline. Every site is a different site. You have you can plan only when you visit a site, and only then you can plan what is best for that site. Now, so now I told so this is a different components of our hydro project: a diversion to divert a water, then a desilting tank which removes the silt available in our system. Because why it is very important? in some cases we get actually during monsoon a lot of silts comes in the river. If but there could be a possibility very less silt available. So don't put desilting. But if silt is there, then it is mandatory. Water conductor system, water to take the water power generation at the end four-way, from where a pipe called penstock, then a powerhouse for power generation. In the powerhouse, equipments after power generation tail race and water the generated power through switchyard goes to the grid. Now we had three stages: a reconnaissance level, we can say preliminary and PFR actually, and then we had a feasibility, because it is pre-feasibility, it is feasibility and detail also, detailed project, and finally execution. So just see, okay, just you know that at present recently we are our center is involved in 36 PFRs which we received from Kargil area, JNK. Recently, yesterday only we finalized our recommendations for that one. So what happens? So they had prepared a brief report of say 10-15 pages at in the name of PFR. So we had just seen out of 22 projects, we just proposed that some projects to be dropped, some projects to be clubbed. So you know that after our observations, everything. So 22 projects which were earlier there, they reduced to 14. So you know that that's why a investment of 1 lakh per site could be sufficient to prepare a PFR. So on that basis, you know a lot of information. You know what happens when I was in I was a member of UNDP project. They were to develop 20 projects within a country, and we just got 4 DPRs of mega. I think it was of Meghalaya, and you know that around 100 kilowatt to 500 kilowatt, and very big reputed private consultancy firm prepared the report of 100 kilowatt of 3 big volumes. So criteria was the site which were having a detailed report ready, they should be developed first. Those reports was referred to AHEC and it came to me. After seeing those sites, maybe I took around only 1 hour to see, and I proposed these projects to be rejected. Why? Because those projects were developed only 20% dependability, means they just utilize monsoon discharge and say 100 kilowatt, 200 kilowatt, up to 200 kilowatt. What happened if monsoon, after the monsoon, the discharge was reducing by was 1/20th, means 200 kilowatt project was going to be 200 by 200, around 10 kilowatt. I just mentioned that these projects are worth reducing around say they should be developed only 10% of the capacity which they proposed, means everything to be redesigned. So but due to the pressure of the government, state government, the site was UNDP officials visited those sites. They could not find, because what happened, because their sites were not to be visited during monsoon, and after monsoon there was no water at those sites. So the officials could not say these are the sites where we want to put up a plant, because there was no water. So at preliminary PFR level, you need finally go for those sites which has really a potential. Then you invest, because PFR is just on the basis of the models available, you can develop, yes, these projects are of this capacity, if that is okay, then go for detailed project report. And a lot of things get changed during execution, that I will discuss now. So at the reconnaissance survey, hydrological survey, topographical, geological, power load demand, socio-economic, height, discharge, technical feasibility. Although it looks like a lot of things to be seen, but maybe one day each is sufficient for these the survey. Hydrological survey basically a discharge availability. What you can just find visit the site and find out the discharge at that time, and you can ask from the villagers what is the variation of discharge. Topographical survey means just see where you want to locate, whether they are good enough to make our the location of those structures. Geological means basically we are more concerned about the landslides prone area should not be there. Power load demand means basically it is generally I'm talking about a very remote site where the projects are located in isolation, and you just find out, say, what is the load they can consume. So if suppose they can consume around 50 kilowatt, future you can see 10 15 kilowatt more, say 60 kilowatt, then don't put a project more than 100 kilowatt. Why? If suppose you potential could be of 1 megawatt, if you put up a plant of say 500 kilowatt, so maybe your machine will not run when the discharge, because what happens if your consumption is 50 kilowatt, so it will draw that much amount of water from the river for power generation, because you cannot generate and store in the grid, it has to be consumed. So if the consumption at the site is 50 kilowatt, whatever the water is available in the river, only 50 kilowatt corresponding discharge will be utilized. So it will come, and your machines had a cutoff limit. If your machines are of 500 kilowatt, they cannot run when the discharge reduced to say 100 kilowatt. 1/5 of the discharge they will be closed. So they had a different cutoff limit. After cutoff limit, whether the water is there in the river, you cannot generate. So that is a very important is power load demand. Socio-economic is actually what happens. Here what you do, you will find out when the electricity is generated, whether it can be if suppose they are not able to consume, you can plan some livelihood activity, which we had a project from MNRE to develop a livelihood activity plan for 10 villages, for 10 SHP projects in Bageshwar district. So we had provided under that project the sawmill, the oil expeller, welding machines, computer center. So 10% grant was available from the users and 90% from the government. So likewise, the study was carried out. And for that one, you need to find out. So this is basically the reconnaissance survey can be done by altimeter for the head and GPS. And the total station we can use for the detailed project study. And for the head, very approximate with altimeter, GPS also very approximate. And if you are using the theodolite or so, a very accurate head determination could be there. These are the GPS, which you will see it looks like a mobile phone, and the principle is same. On that basis, so in a mobile phone, yeah, basically the location which you get in the mobile phone, the same principle is applied here. You get a location, but here you get one more additional parameter of the head. Now detail maps, these are survey based, which I told you they had a contours shown on the ground on these sheets. So you can find out the difference in the levels, and you can find out the head available. And this is a very crude method. What happens, it is a water filled tube. You can I maybe nobody generally, it is what happens, you just see a person is sitting here, and at the location of diversion, a lady is shown standing at the location of your powerhouse. So you just have a water tube filled, and you just see the water level, and you can measure the head. So do you have any question, or you can mute your mic please? Some disturbance is there. And this is a engineering level, telescope theodolite is there for that one. Now the in a power equation, that was there was a head, and second is the discharge. For the discharge, a lot of methods I had written here. And these investigations are some more investigation has been added when you are preparing a detailed project report. It is a environmental survey is required, and a survey for construction material, because when you are going for a construction of a project, you need to know from where you get a construction material. Okay. And power evacuation is also a survey is required, to assess the cost of the line. Now I had shown these are the equipment to be used for power. The survey, this is survey equipment which I am showing you. And when you plan a survey sheet, so on the survey sheet, you just mark your locations, and these are the contours which I had shown here. And I had marked, this is general layout drawing which you need to prepare when you are preparing a detailed project report. So for that one, this is your draw all layout of project on a topo sheet. So a total station is there, which actually this is a very detailed map you can prepare on the basis of this total station. Actually what happens in case of the previous equipment which you had seen, you have to find out the contours, you have to find out the level of the point, and after that you need to draw a contour yourself. Actually contour, what we say, our the topographical survey gives our 2D information, means just like GPS, where is the location of our diversion, powerhouse, penstock, etc. These are the 2D information. But in third dimension we need to know the difference in the head of elevation of our diversion and powerhouse, so that difference between these two can be used for power generation. That is a head available. So in case of a total station, so they automatically save the elevation of these points. And and what happens, suppose there are 100 points, elevation has been collected during the survey. So you get all points of equal elevation is a contour. So what we do, we just join all points of say 100-meter elevation, 200-meter elevation, 400-meter elevation. Although no, you will not see on the ground any line joining these points, but these, that's why they are called the imaginary lines. But they are very important. They gives the information about the level difference. So with the total station, these information can be obtained directly. So just see, these are the points. So all these points we had collected. So these we had a elevation also. So after that we just join. So you just see these are the straight line, but these are not the contours. These are the point surveyed. And after that we know the elevation of these points. After that all these points of equal elevation will be joined. So they becomes a contour. Now a flow measurement is very important, and you have to measure very accurately. This is a when we are having generally we just we get a discharge observed through a rectangular notch. What we made, we just make our the river section to flow in a rectangular portion, and that portion is so we just measure. So if we know what is the length, if we know what is the water depth, so this can be, the discharge can be calculated by this one. This is a analytical equation which we had got it. If the discharge is less, say a V notch here can serve the purpose, then in that case we don't require any the width in this formula. And now, and when the river is very wide, so we just have a area velocity method. What happens, this shows the cross section of the river where the discharge is flowing. So we just divide the whole area maybe in 10 intervals, equal intervals along the width, and these are the depth at different elevation, different point. So the depth we know, water depth, we know the total width. So we can calculate what is the area available for power for the discharge flowing, and we measure the the velocity at these sections, or though and then we calculate what is the discharge available for power generation. Now there is a one more method for in the turbulent stream, where you just see in a hilly area where you don't have the any means of having a V notch, rectangular notch like this one. So for a turbulent stream, a very good method is available. That is a salt method. What happens? What happens? This is a flow which is a turbulent stream is there. So we start pouring a salt here, and after say after 25 times of the what is the width of the stream, so 25 times of the width downstream of this one, so we just start having a measurement, and directly we get the discharge of this stream, provided. So what we just pouring a salt here, so provided this is should be so turbulent that it is thoroughly mixed. So at this section the salt should be thoroughly mixed. So now I will show you the relations which are available. So it is a salt method which we call. So this is a equation which is available, and so here the discharge is m upon k into a. What is the m? Is the salt you had used for this measurement. K is the conversion factor. A is the area which you will see here. So actually this is, you have to calculate the area here. You have to calculate the conductivity. Conductivity initially at the measuring point. Conductivity, so when the salt is mixing, okay, so slowly it is getting the conductivity is increasing. Finally then it will start, you stop mixing. So after 10 the time is given, and then the conductivity will start come to the normal. So you calculate the area, and salt used in this one will give you the directly the discharge. And for that purpose you need not to pouring station should be 25 times above the measuring station. And for calculate, you can calculate the quantity of salt to be utilized. You calculate the average width and depth of the measuring position. And this is a this one. If your basic conductivity is in between 0 to 100, 100 to 500, 500 to 2000, and multiplication of width and depth, very small stream where the width and depth is 0.1, very big stream where the width and depth multiplication is 1, so you can get this much amount of the required, this much amount of our the salt. Just see, hardly anything, it is only 1 kg. Now so this I had told you the discharge, the steps of measuring the discharge for a salt method. Now now after this one, so we had calculated what is the discharge available. We had calculated what is the head available. So now in this method, in this one, we had just shown you know that a very important one is we are putting a project. So I had discussed here where to locate a weir. Weir should be located where you had a minimum width of the river, stable slopes. You should select a site. Site should not be just see, this should not be like this one, that this is a residual soil which is deposited in the river. Landslide area should be avoided. Glacial moraine should be avoided. And okay. Okay, loan demand survey. I told you that you cannot. So when you do a so this is location of the weir. So that I had not discussed other location like your the 4B, and so they are not. They will not affect the power potential. Only power potential will be affected if you locate the site of the weir upstream. Your discharge will reduce. so get less power. If you locate the site downstream, your discharge will increase, get more discharge but less head. So very important one is the location of the weir. And when you do a load demand survey, so take everything in load demand. What is the domestic requirement? What is the street light in the area? Growth in the load demand, because generally we project, we just have the load demand for 10 years. I told you that there could be a question, why don't we have load demand future growth for more than 10 years? Because you know that our machines, if suppose future today present is 50 kilowatt, future maybe 10, but next 30 years could be 50 or more, so it become 100. But you know that if you put up a plant of 100 kilowatt, so your plant will run at half of the capacity is 50 kilowatt. So you just see, you, if suppose your machines are or your machines are of 100 kilowatt, and they are running on less power, so they don't, if the, so if the discharge is for 50 kilowatt, so those machines will not develop 50 kilowatt also, because their efficiency, which I told you 88% to 94%, when the machines get 50% of the discharge, because of two reasons: either discharge reduced during winter period, or load is less at site, so consumption, so they are, you are drawing less discharge for power generation. In both the case, machine will get 50% of the water. So when it is 50%, then your efficiency will not be 84%, efficiency will be 74%. So automatically 10% energy is lost due to efficiency. So don't put a oversized machine at the project, because efficiency of 88% you will get only when machine will generate 100 kilowatt, 10 megawatt, generating 10 megawatt. If machine are of 10 megawatt but discharge reduced to 5 megawatt, so efficiency of 84 will reduce to 74. So it will not generate 5 megawatt, it will generate 4 megawatt. So so whatever rated one is, load survey is very important. How much you can consume, put up the project of that capacity. Meteorological survey is for assessment of the catchment area water availability. Construction material, when you will develop a project from where your material will come. Environmental survey, actually you know that earlier we were not aware of the environmental, whatever the whole the water was being diverted for power generation. Later on these things have come up. Now it has become mandatory that you just have a total discharge, collect the information, and 10% of the discharge during lean period should always be flowing in the river for our environmental reasons. So that has become mandatory. Now, during a execution of the site, certainly a lot of things are required. You know that you need to know, find out a geotechnical. You know that although the geotechnical investigations are done during detailed project investigations, but a lot of geological surprises are there. Maybe you, when you just put up say a plant, say you are constructing a tunnel, so maybe at the site you will have a borehole just to find out what is the geological conditions. When you just make a tunnel of say 2 meter diameter, maybe a lot of things are changing. So a lot of change may be required for when you do a execution. Site selection, I discussed that when you are having a weir, so these are the normal trend which you will find. So it should be narrow. Why? Because this will very costly if you have a bigger length. And so this is the ideal site, because turbulence should also be avoided when you have a weir site. Now, other desilting site and four-way site, maybe a lot of things may have to be seen. Flatter land so that construction is easy. Cross drainage means you should not have any stream nearby. slide zone should not be there. The same thing should go for 4-bay and other components. And penstock, you just see when we have a penstock, so it should always be along the top of the area in that one, because penstock runs from the top of the hill to up to the near the river, where the powerhouse is there. So it should be, whenever it is laid, it should be laid at the highest point in that land. Otherwise, what happens during monsoon? The water flows. If suppose it is the lowest point, water flows flows in that narrow gorge. So so it is damaging. So now. Uh, uh, um, Yes. So this I had shown some of the slides when which is very important when we are having a topographical survey sheets available. We just see all the things which I had discussed with you. Okay. Uh, 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 um, I think so. This is a divergence site. Maybe it is not at the band. Maybe the band is looks like, but it is not the band at the site when we planned it. If it is a band, we should have shifted a little down here. But after that, I had shown a channel alignment here. And you know that I had, these are the contours. Contours can help to find out where is a flatter land or not. So you know this 4-bay tank is a tank where we just have our the tank which we had are putting for our power generation. From there we are taking a penstock. So you just see we just shifted that the actually contours have just shows the pointed nose. So pointed nose is always either at the top of the area or bottom of the area. So at both so when they are the pointed nose towards the river, so that shows the top of the area here. When the pointed nose is away from the river, so they shows the valley. That shows the valley. The pointed node earlier we just planned our penstock. Pointed node was here, but in half of the length, pointed node shifted little bit. So we shifted our penstock alignment by shifting it here. Just see here. Yes. See what I was telling. These are the contours which our total station will draw. These are the pointed nodes where our contours are taking turn. These are the pointed nodes our contours are taking turn. If pointed nodes are away from the river, so they shows that a river flowing, a small stream flowing. When pointed node are towards the river, this shows this is the highest point in the area. Water cannot flow along this one. Water has to flow on both sides to reach to the lowest point. So this is the best site for our penstock alignment. Now, when we just these are the few more slides which I had added. So basically what happens when we just plan our power projects, we are very much critical about the head assessment. So we just draw a water conductor system, and you know that this is a diversion point, desilting, then channel, and the 4-bay. Actually, we have to find out what is the head available, level difference between 4-bay and powerhouse, and how much is the loss which has occurred in this a pipe in between 4-bay and powerhouse. That is a loss to our part, because in a power equation of potential energy, 9.81 Q into H, H is the head which is available excluding head losses. So we are very much concerned about that one. So this is a discharge data which we had collected by our various method. So now this discharge data we had arranged in a descending order. So you know that when we so I had shown a monthly data of January, average monthly February data, December data, and this data I had arranged in a descending order. So This data is for 30 days available. Remaining 11 months data is reducing. So 50% means this data is available, this data or higher discharge for 6 months, and others are reducing. And the lowest one is the minimum discharge. So this is called a 100% dependability. So I had discussed about 50%, 75%, 90%. This is 50% means 6 months discharge data, and corresponding potential is 6 megawatt. 75% time discharge available is 4.1 or higher, and potential is reduced from 6 to 4. And around 90% dependability, again the same, no change in the potential. So then I had developed, this is a flow duration curve. So this shows that 100% minimum discharge throughout the year is this one. So this shows us that generally for our projects are connected to grid. So the discharge which is available for 50% time should be developed for power generation. And if you want to go little more, means higher dependability, means you are reducing a discharge, then you have to calculate that how much expenditure you are doing. As you are increasing the size of the machine, structure cost will increase, equipment cost will increase. So with higher size machines, certainly you will generate higher power, but only for monsoon period. So you have to calculate that total expenditure is this, then total revenue is this. So what is the generation cost now? So we calculate the generation at different dependability. So if we put up a plant of two machines of 750, so maximum generation is power potential is 7 megawatt, but we are generating only 1.5 megawatt. We can have two machines of 1000 megawatt, two machines of this one. So so that's why we do water power strategy, to show that how much we are generating, then what is the plant load factor, and how much energy we are generating. So as we increasing our size of machine, so certainly our energy is increasing, but PLF, which I had discussed in detail, is reducing. The machines which you are put up, it will be utilized for 82% time in a year. Remaining time, we remaining time, our utilization will be only 82%. So I had given a small example where the 50% time. So this shows dependable discharge, 50%, 8.8, 75% dependable 7, 5. This is 90%, 6, 5. So reducing, because certainly we know that if we want to have a discharge 100% available, means minimum discharge in winter. So during so if we are so potential discharge is reducing, potential is reducing. So we calculate a power potential at different dependability by changing the discharge, keeping the head same, because head at each dependability will remain same. So we fix up what is the potential to be utilized. Then we just have that how much energy. So we generally have two machines minimum, because during winter our discharge reduced to half. So maybe if we provide only one machine, the efficiency is 10% reduced at winter discharge. So it is better to have two machines of equal size, half of the rating. So when the discharge reduces, other machine will run at full power, 88% efficiency. And you know that we have to plan our project for annual maintenance. During that period, when our one during winter our one machine is giving full power, other machines may be opened and for maintenance. Now we calculate the discharges of different components, and I am concerned about the discharge which is passing through my penstock. because penstock discharge is more important for calculating the losses. So you just see I had shown again a penstock actual project, because you see a project name and so many signature. Signature is also when we send this site to drawing to the site, we put a signature also. So we calculate what is the level in the forebay and the in the powerhouse, and all peristalk length accurately calculating the loss. And this is the length was 162 meter in this case. And main loss in the penstock is a friction, which depends upon the Reynolds number and friction factor. So I had given you a curve required for calculating the friction factor loss. So these are the losses which are there in a penstock system. And then just see length, number of friction loss. I had given a formula FLV square by 2GD. So so this is a formula is given, and other losses are calculated. The friction loss depends upon this one. Then I had considered exit loss, band losses, and I had calculated total loss. Total loss was 4.33 meter in this system. So basically, the level difference between forebay and powerhouse, difference of this, I have to subtract 4.33 to get the head for power generation. Yes. So this, let me check it up whether for calculating. Yes. Yes. Just see the level difference between the forebay FSL in forebay was this level, and at the powerhouse was this. The total had which level difference was 96 meter, and 4.33 which I had calculated at the end of my table is the loss in the penstock from forebay to powerhouse. So which I had subtracted, it is 92 meter. This 92 meter was used in calculating the potential of this site. Now, so although it is a when so now this I had shown these two slides more because the head which you are getting is not always, just see this. I had shown one type of the turbine which is a Pelton or cross flow turbine, where the powerhouse level is considered at the center line of our the penstock which is going in the powerhouse. So the level of this penstock and level of our the FSL in forebay, the difference is was 96 meter. But in other type of a turbine, those are called reaction turbine. A Francis and Captain are in that category. We get slightly there we get 1.5 meter more head, because there we consider the water level in the where when it comes in the channel flowing. Actually basically if we go where we get a air in contact, in case of a Pelton turbine and cross flow turbine, we get the water discharge coming out from the nozzle as a jet, and water get in contact with air here. So that's why we get central line in case of a Pelton turbine and cross flow turbine. But in case of a Francis turbine or axial flow turbine, I had shown this one. Water is under pressure here also, negative pressure, and it comes in contact with our water in the tail race channel. So here the level, forebay level is same in both the cases. Powerhouse level is not at the center of our penstock. It is at where it is releasing the water in the tail race channel. So in case of a reaction turbine, we get around 1.5 to 2 meter more head in comparison to a cross flow or Pelton turbine. So, but there are other considerations also. Maybe you will get cost of these turbines, Francis, are more. could be maintenance is more, maintenance cost more. So a lot of things are also to be considered. But as we are concerned, only will the head availability and potential steady. So there are one more the point to be considered is the type of turbine. When we go in very detailed, otherwise normally whatever the water level, whatever the elevation of our powerhouse, whatever the elevation of our forebay, take the difference and take around 8 to 10% as losses when the water runs from the forebay to powerhouse. Okay guys, now this is a last slide which was there. So now I will request the participants, because we had at least 10 minutes with us for questions.
So, dear participants, please unmute yourself and you can have any questions. Please clarify.
Participants have to unmute first, only then they can ask the questions. And you know that maybe I can be able to give the answer of your practical problems also, because maybe we are involved in around 200 300 potential development preparation DPRs and other things also, and from construction point of view, from planning point of view.
So, participants, please unmute yourself and if you have any doubts, please clarify.
Sir, what would be the strategy of wind turbine in case in future we don't know, because we are not getting good efficiency from the wind turbine, right? So, like investing huge amount in the wind turbine, okay, wind energy, but we are getting output efficiency is very less. So,
Actually, dear
have
participant,
suggestion?
I could have, because my topic is not renewable energy.
Okay, okay.
My topic is hydropower potential assessment and
No, no, but
investigations.
okay, fine, fine, fine. So just this is just
Otherwise, also,
I thought it
otherwise
would
also,
be
just maybe because others are not asking any questions, so I should answer your question. You know what you want. Actually, whatever the availability is there.
Mhm.
So actually, you just see, we as a consumer, we cannot develop a machine. Okay,
Okay,
we
okay.
have to use the already available machines. And you know that a lot of wind farms are coming up, have been developed only when they are commercially viable. And
Okay.
you know that earlier when we were the king in the renewable energy hydropower,
Mm-hmm.
which we became beggar because of solar energy only. When the
Okay.
solar energy started, it was 25 rupees a unit,
Okay.
which government has made a MOU also. That
Mm-hmm.
energy cost has reduced to 3.75 or 4 rupees,
Yes,
maybe
certainly.
half of the price which our hydropower, small hydropower, is giving. So
Yes.
when you have a demand in the area,
Okay.
because you know that our central government now had a plan of around 200 gigawatt, means 2 lakh megawatt development of solar energy.
Yes.
All thrust is going to solar energy. And you know that now they are I had seen somewhere that a 700 megawatt solar energy plant with battery backup, because the problem in the solar energy is the storage. Means,
Oh,
or storage means, although it can be consumed in the grid, but the problem is when you demand, then it is not available. Means
okay.
speaking, you cannot have. So now I had seen one the tender also in the south for 700 megawatt with battery backup. It
Okay.
is to be stored in battery so that meet a peaking demand. And at that time, with total cost was going around 7 rupees a unit. Means
Yes,
cheaper than the any other means of the energy.
yes, sir.
Okay. So it basically the more efficient machines will come up when the demand is more,
Okay.
the cost will go down, and certainly as a consumer you will develop only those projects when you will be having, or if suppose machines are not efficient, then you get some grant from the
Okay.
central government or state government, because they want to develop this project in their area. Is right.
Sure, sir. Yes,
So
yes, yes.
basically we cannot think of making more efficient turbine ourselves. It is a manufacturer has to go, and manufacturer will go only when he
Okay.
gets it. And one more thing I want to clarify here,
Fine, sir.
that
Fine, fine.
if suppose you had 100 megawatt plant, okay, and you ask bidding.
Okay.
So as per the bidding requirement, if suppose somebody is quoting for 100 megawatt, say 1% efficient turbine, okay. So as far as the tender is concerned,
Okay.
both are qualifying. But a person who is providing
Okay.
a higher efficient turbine, he get 5% extra credit off in the cost. Means if his cost is 4.5 times extra, percent extra, no times. Suppose a
Okay.
person has quoted
Okay.
100 crore,
Okay.
and person having a efficient turbine quoted say 104 crore. Although he has quoted more, but
Okay.
he will be considered L1 because he is giving you a efficient turbine
Okay. Because of good
because
efficiency.
of the higher efficiency.
Okay. Yes, yes, yes.
Is right. So just to
Okay.
so that
Yes, sir. Yes.
just we want that everybody should come, and that another one more thing may come up here. That sometimes manufacturers feels that we don't have any means to just measure efficiency. Okay. So in that direction also, now in hydro sector, earlier we were getting because it was a manufacturer's prerogative to write their efficiencies, because they were knowing that nobody will be able to measure efficiency. Now there are institutions like our center. We had we have been asked by MNRE to measure the efficiency of the equipment of those projects where MNRE subsidy is being provided, because government does not want that the less efficient equipment, efficient total efficiency should not go less than 75%. If a machine, if we find out that efficiency of the machine is less than 75, then they will not get subsidy from the MNRE. Is right. To encourage the persons manufacturers to develop a efficient turbine, okay. So a lot of schemes are coming up from the government side, and when the demand is more, so you will get more consumers. Any other question, please?
Fine, sir. Thank you, sir.
Okay, then
Sir,
I stop
sir,
sharing, then I can leave the site
sir,
now.
good afternoon. One more question, sir.
Yes, please.
That is not, I think, related to that course. It is a general question regarding
Yes, please.
Tapovan incident.
Yes, please.
Why that hydro project washed away? That is a design failure or something else, sir?
What do you feel?
I think they haven't considered that the natural disaster, or I think that is first time that happened. So much natural calamity.
Do you know it is a cloud burst? Cloud burst means that
Yeah, I know that happened in
okay.
that Kedarnath or
So just see if suppose we just anything can be designed, number one.
yeah,
If suppose you want to consider the cloud burst in our design problem,
yeah,
so our dam should go maybe 20-30 meter deep to get an anchorage. The width of the dam will go around twice of the what has been provided otherwise.
yes, sir.
Okay.
Okay,
So you just see every project can be designed for anything,
yeah,
but at what cost? That is a problem.
yeah, yeah.
Okay,
naturally.
so normally we design, because what we do, we just our all civil structures which we design generally has a life of 100 years. So what we do, we just collect a data from the field, whatever the record is available,
Yes,
what the maximum flood has occurred in 100 years time.
yes, sir.
For that purpose, we just make our structure safe for that flood. We can collect a data of 1000 years also,
Okay, sir.
and we can increase that data by 2 times also, just to take care of any calamities. But the problem is, at what cost?
Naturally, cost will keep
है
on
ना? So
increasing.
everything becomes unviable.
Yeah.
So I think it is not, maybe it is not in the interest of any project.
Yeah.
Is
Okay, sir.
right? Okay.
Okay, sir. Thank you very much.
Okay, guys. Then thanks a lot. Have a patience, having a patient sharing from me. And you know that if any maybe at a later date you had some problem, some questions coming up in your mind regarding hydropower, so that can be mailed to our head. You had our email address on website also for our center. Okay, we will be happy to ask to answer any questions whatsoever from your side. Thanks a lot. Then I'm leaving the site, and thanks a lot, Reddy ji, to
So
give
we are
me
concluding the session, sir. So on behalf of the RGM set and mechanical department, and on my personal behalf of, I am very much thankful to you, sir, Professor Mukesh Kumar Singhal, sir. At the same time, to Professor Sunil Kumar Singhal, sir, also. So you have given a valuable information to our participants and a valuable time for us also. So thank you, sir, once again.
Thanks a lot, Reddy ji. Or and I will send you my PPTs to you, and you can share these with the participants.
Okay, sir. Thank you, sir.
Welcome, sir.
Bye. So, dear participants, within 5 minutes, we'll start the valedictory session. So, and then we'll close. Please be patient. స్టార్ట్ చేయాలి సార్, జాయిన్ అయ్యండి. సార్ జాయిన్ అయినారా? ఉండు, మీకు ఇది లేకుండా ఉందేమో స్పేస్. జాయిన్ కాండి. ఏదో దాంట్లో జాయిన్ గా ఫస్ట్.
హండ్రెడ్ రీచ్ అయినట్టుంది, 100 దాటితో తీసుకోవాలంట. హలో సిద్ధార్థి.
సార్
100 రీచ్ అయిందని జాయిన్ చేసుకోలేదు, ఇప్పుడు మళ్ళీ జాయిన్ అయ్యాను ఇప్పుడే.
ఓకే ఓకే
రైట్, క్యారియర్.
ఓకే, స్టార్ట్ సార్.
రైట్, విల్ స్టార్ట్.
So good afternoon, good evening to everyone, and sorry for the delay. So myself, Dr. B. Siddharthi, Associate Professor in the Department of Mechanical Engineering and Coordinator of the Faculty Development Program. So I am very happy to welcome you all for the valedictory session of 2-week online Faculty Development Program on Renewable Energy Interventions in Industry, Commercial and Domestic Application. So first of all, I would like to thank our beloved Principal, Dr. T. Jijana Prasad sir, directors and deans and HOD of Mechanical Engineering, and the invited speakers and the participants, so for taking your time off from your busy schedules and making this evening with your glorious presence. So the faculty development program was aimed for faculty members, research scholars of various engineering colleges who wish to become the facilitators of the student community. So we had a overwhelming response from the participants. About more than 560 were registered for this faculty development program, not only from the mechanical engineering and also from the various disciplines of science and humanities across the India, and not only India, from the abroad also. So this faculty development program was planned with 24 lecture sessions and 3 virtual lab tours. So we have the 500 kilowatt solar PV plant, which is installed in the RGM set Nandyala, and a soya milk plant and a solar thermal lab. So all these sessions were handled by highly experienced and upcoming experts. They are doctorates from the IITs and IIScs. So all the resource persons were drawn from the reputed institutions like IITs, NITs, and also from the reputed research organizations like National Institute of Ocean Technology, National Institute of Wind Energy, and also the industries like SSV Industries and ONRG Industries and Senvian Technologies. So this program, the brief report on this 2-week FDP are like this. So Professor Hemchandra Reddy sir, Professor of Mechanical Engineering and Chairman AP State Council of Higher Education, inaugurated the program on 15th February at 10 a.m. along with our principal, directors and HOD of Mechanical Engineering, and the chief guest spoken the importance of different types of renewable energies for rural sustainability. And then the sessions were started. The Professor S.C. Kaushik, Center for Energy Studies at IIT Delhi, has explained the utilization of solar energy for refrigeration and air conditioning. And then afternoon session, the Shantanu sir from IIT Kanpur explained the impact of CO2 emission, carbon capture technologies, methods for CO2 separation and CO2 utilization. And then Professor K.S. Reddy sir discussed the solar energy harvesting with his technologies for industrial process heat and power generation. And then Professor Sivardi sir, RGM at Nandyal, discussed the renewable energy technology solutions for sustainable development in concerns with the environmental problems. And then the speaker Bhanuchandar from Senvian Technology explained the design procedure involved in the wind turbine generator and the cost of power production and the effect of various parameters on the coefficient of performance of the wind turbine. And then Sri Sripani Viswaraju from SSV Energy and Infrastructure Private Limited outlined the diverse applications of solar PV. And then the speaker A.G. Rangaras from National Institute of Wind Energy explained the basics of Python programming and how to use the Python programming to the renewable energy data analytics. And then the Panikumar, the scientist from the National Institute of Ocean Technology, discussed the different types of solar collectors and its cost analysis, and explained the solar-based multi-effect desalination plant which is installed by the National Institute of Ocean Technology at Kanyakumari, and also explained the research opportunities and also touched upon the tidal energy. And then the speaker, Professor Dr. Satyashekhar from IIT Jammu, explained the present technologies available for hydrogen production and options available for hydrogen storage. And then the Professor Narsimulu Sankhe from Osmania University shown the production of energy from biomass through his experiments. And then the Dr. V.P. Chandramohan from National Institute of Technology, Warangal, explained the analysis of solar dryer using CFD and software tools used for modeling, flow analysis, plotting the 3D results for curve fitting and correlations, and also programming tools used for heat and mass transfer models. And then in the afternoon session, the Mr. Sweta Maheshwari Jaju explained the interventions of renewable energy for agriculture. And then Naga Srinivas, in the second week, the Naga Srinivasulu discussed the proton exchange membrane fuel cell system, voltage losses, and flow field plate designs. Sir is from National Institute of Technology, Warangal. And then in the afternoon session, Dr. Manavendra Pathak sir from IIT, IIT explained the design and development of a portable parabolic trough collector for household applications. And then Meenakshi Rathor, ma'am, explained the green building concept and the key components of green building and its advantages, and also explained the case studies and certification procedures. And then Piyush Jaju sir, co-founder and CEO at ONRG, given the smart decentralized solar technologies through IoT, solar for solar lighting, so irrigation, microgrids, and rooftops. And then Dr. K. Arun Kumar from Central University, Kerala, so sir explained the energy conversion and production with algae as a biomass resource. And then Narendra Singh sir from IIT Tirupati has given the outline on the solar cells, ongoing trends and future challenges. And then Dr. Subbarao sir from IIT Delhi has explained the concept of sustainable energy self-sufficient village using waste biomass and explained the thermodynamic classification of living species and second law analysis of biodiversity. And then again, Sripani Viswanaraju sir discussed the eco-friendly living. And then we had a good interaction between the speaker and the Dr. Ramesh sir and Dr. Jaji Varghese sir for a longer time to clarify the doubts also. And then the speaker Bhupati elaborately given the procedure for design and modeling of a wind turbine and its challenges. And then Professor Mangu sir from Osmania University explained the introduction to power evacuation strategies from solar photovoltaic energy systems. So after that, the Professor S. Murali Mohan sir from NIT Warangal explained the working principle of fuel cells and flow batteries. And finally, the speaker, Professor Mukesh Kumar Singhal from IIT Roorkee, delivered the talk on potential investigations and assessment of hydropower plant. So we think that all the participants may gain the knowledge in a basic application of various renewable energy technologies for the solution of sustainable development. So with this knowledge, the participants can convey the information to the student community that may result the holistic development. So this is the program happened in the last 2 weeks. So with this, I request today's chief guest and head of the department, Professor Tirupati Reddy Garu, please speak a few words on this occasion.
Thank you, sir. Thank you very much for your valuable words on this faculty development program. Thank you. Good evening, one and all. Myself, Dr. K. Tirupati Reddy, Professor and Head of Mechanical Engineering. First of all, let us thanks to AICTE for sanctioning this two-phase faculty development program on renewable energy intervention in industry, commercial, and domestic applications. Dear all, you know very well that the phase 2 is commenced from 14/12/2020 to 16/12/2020. It is successfully completed those weeks. Because of the corona problem, the phase 1 is started recently from 15 to 2021 to as and today, that is 27 to 2022 21. Let us thank all the speakers for attending this program. And before that, let us thank to our chairman, Dr. M. Santramadu Garu, and our beloved managing director, Mr. M. Sivaram Garu, our beloved principal, Dr. M. T. Jason Prasad, directors, faculty, and staff and students of mechanical engineering. Thanks one and all. And let us thank all the speakers and this phase 1 chief guest, Dr. K. M. Chandra Reddy, chairman, APSI, Vijayawada. And also let us thank all the participants for your valuable participation in this 2 weeks faculty development program. Hope this faculty development program will enlighten all the PG students, faculty, and PhD scholars. Friends, you all know very well that the importance of the renewable energy. Nowadays, the fossil fuels are complete within years. It is completely absolute. There is the next alternative, the alternative energies, that is solar systems. In future, there may be a solar. In future, the future era is the solar only. Without that, it is not possible to solve the energy problems in future years of this. It is a right time for all the researchers to take this as these alternative energy sources as a alternative problems or research problems to do your research and conduct problems. Friends, we hope all the faculty, all the speakers will enlighten you all on this renewable energy intervention in industry and commercial and domestic buildings. Hope you are enjoyed all the sessions on from 15th February 2021 to 27 February 2021. I once again thanks to the coordinator of this program, Dr. B. Siddhareddy, for giving me this chance to all the audience. And let us thanks to the AACT also for giving this opportunity to the RGMCT Mechanical Engineering Department to organize this type of programs. Hope many number of programs will be you can expect from the Department of Mechanical Engineering, RGM College of Engineering and Technology. Thank you, Vanada. Thank you. Thank you, sir.
Thank you, sir.
If any audience,
So,
audience, you can, if you want, you can.
So please give your valuable feedback. All the participants are requested to please give your valuable feedback against the 2 weeks faculty development program.
Participants,
please unmute yourself and you can speak something about FDP.
Yes, good evening, sir.
Yeah,
this
please,
is
sir.
Dr. Satyendra from Triple IT Una. Sir, it was really a great learning experience about the various technologies related to renewable energy, and almost all the expert talk and virtual lab session particularly have been very informative as well as descriptive. So thank you so much for putting great efforts to organize such a beautiful workshop. I also would like to thank the team behind the screen for the very smooth pace of this workshop. So, sir, no workshop can take shape without a hard working leader. It was you who put forward the dedication and enthusiasm for the great success of this workshop. Thank you so much, Professor Siddhareddy, sir.
Thank you, sir. Please. Other participants? Any participants? Please.
Good afternoon, sir. Good afternoon,
sir.
sir.
Please, sir.
Sir, this is Dr. Naimuddin from G. Pullareddy Engineering College, Autonomous.
Sir, please. Sir.
Actually, I belongs to electrical background,
Yeah.
but I am interested to work in an interdisciplinary work. This 2 weeks workshop is very much useful for me to gain the knowledge beyond my curriculum. Thank you very much, sir. And from the bottom of my heart, I sincerely thankful to the management, principal, and the head of the department, and especially the organizer, Dr. Siddhareddy sir, for providing such eminent persons as a resource person. Thank you very much, sir. Thank you.
Thank you, sir.
Good evening, sir. This is Dr.
Good evening,
Marshall.
sir. Yeah, please, sir.
I'm from Karunya Institute of Technology, Coimbatore.
Sir, please.
It's a wonderful experience to attend the programs this 2 weeks. Even though it's a long duration, like 2 weeks, every day, two sessions, but wonderful resource persons. I'm working in the area of biomass energy and really enjoyed PMV Subbarao sir's session because I'm parallelly working in the same area, and so much of information from other speakers. And thank you so much, especially Siddhareddy sir. Whenever you are always in the screen whenever we see you, and the way the program is organized, and thanking the principal and the chairman of the institute, and thank you for giving us this opportunity. Wonderful learning experience.
Thank you, sir. Any participants? Anyone, please?
Any participants, please? Unmute yourself and speak few words.
So I think no participants, sir. We'll close the session, sir, by vote of thanks. So at the outset, I would like to thank ASCTA for sanctioning the 2-week online faculty development program to our institution and our department. So from the bottom of my heart, expressing my deep, sincere thanks to the management, Dr. M. Shantiramud sir, and Chairman RGM Group of Institutions, and Managing Director, Mr. M. Sivaram sir, and Principal Dr. T. Jayachandra Prasad sir, and HOD Tirupati Reddy sir, and senior faculty Syed Altaf Hussain sir, Chandrasekhar sir, and Naishwar sir, and experts who devoted the time for sharing their experiences for our targeted audiences. So without participants, there is no logical conclusion. So I must thank all the participants, those who joined in the Zoom link as well as in the YouTube link for their unconditional support. And then my heartfelt thanks to our supporting staff, Mr. N. Upendra. So thank you one and all. Thank you for joining and making this program success. Thank you all. Jai Hind.
Thank you, sir.
Thank you, sir.
Thanks to all participants for attending this 2 weeks faculty development program. Thank you.
So dear participants, so I have given the exam quiz link. So all of you attempt the quiz. So I will also provide in the already given in the YouTube also, and also will be given in the WhatsApp also. So thank you. Sir, I will close up. So the quiz link is also given in the WhatsApp also. So all of you finish in an hour.